Hello, I'm Florian Rooz, the discoverer, I guess you could say, of the law of exception. Welcome to the law of exception channel. Please like and subscribe. Even though this is the first video we're posting on this channel, the probability is high that this is not going to be the first video that you watch on this channel. It's much more likely that you will choose to watch this video after you've seen some of my future videos that I will be posting. Now, it's okay if you haven't seen any of my future videos yet, maybe they're not even posted yet when you're watching this. Actually, it's great to get the entire insight from the beginning, from first principles. However, most of you in the future will have seen or heard something about the probability limits and probability maths already if you're watching this. Also, many of you will have seen my future video, especially on how we can now model the inside of a black hole using probability numbers and probability maths, and that we actually finally understand what is actually happening inside of black holes, which form the core of pretty much every galaxy that we know of. So most of you will be wanting to understand, where did these mysterious and strange probability numbers and probability maths come from, and why are they able to do what no other math could do before? So this is all about the law of exception. What I discovered is essentially what the fundamental structure of energy is. So you know Einstein's famous E is mc squared. The E in there stands for energy. Now, Einstein's law beautifully describes the relationship between matter, stuff, and energy, and how you can convert one into the other. But Einstein himself was very clear and honest about the fact that he still had no idea what energy itself actually is. Something similar happened with Isaac Newton. With his famous equation for gravity, Newton also described accurately and beautifully gravitational attraction. He described it, he described very precisely what was happening, but he fully admitted that he had no idea why or how it was happening. And this is where the law of exception goes further, because for both of these equations and many others, it provides the answer, finally, that doesn't just improve on both Einstein's and Newton's math and their equations. It actually tells us why we have mass, what mass actually is. It explains to us exactly the reason why we have relativity and why we have other phenomena like time dilation or duality. It essentially answers all of those really big questions kind of in one fell swoop. And it does that because it describes the fundamental structure of energy. So by completely changing our understanding of energy, you will see that all kinds of long-standing mysteries literally will kind of dissolve in front of your eyes. And I'm talking about very serious, large things here. Like, we're going to talk about how I constructed the probability numbers, and you will literally see all but one of the prime numbers just vanish from numbers altogether. So things like 3, 5, 7, 11, suddenly they'll just stop being prime numbers. Now, if you haven't seen it yet, I know you'll be saying something like, there's no way that you can divide 3 by anything but 1 and itself. But it really is actually possible. It's one of the oldest mysteries in maths, yet you will see prime numbers disappear like snow before the sun, just by applying the law of exception. And even the very attribute of even and uneven numbers will just disappear just by applying the law of exception. So you'll see me create a math system that literally defies the mystery of duality and that generates new equations for gravity, mass, energy, time dilation, all of those things. And they give us roughly the same or very similar answers to what Einstein, Newton, and many other people found out, because they found the right relationships. But this time we're also going to understand why we get that answer. And so that makes it a completely different beast. So Albert Einstein kind of proved that everything around us, all stuff, is made of energy. He just didn't have any idea what energy itself was. But once we understand what energy really is and how it works, then that knowledge kind of instantly shows us how everything works, because everything is made of energy. That is why it's the law of exception, because it describes the most fundamental, exceptional thing that there is, energy itself. What is it, and why does it do what it does? Well, let's get into it. So we have to start by talking about uncertainty, but not just any uncertainty. We have to get very clear on the uncertainty inside of human languages. I'm communicating using English so far, but here's the thing. The true law of exception, the structure of energy, is so paradoxical that it cannot be described very well using any symbolic language like English. If I showed it to you right now, it would just look like a bit of a strange, quirky phrase to you. It's only when you look at it in a certain way, kind of an unusual way, that you'll be able to see the structure that's hidden inside of the words. And it's that structure that is the actual real law of exception. So how do we do this special way of looking? Now, to teach people to do this, I constructed an art piece that's specifically made to show you how this works. So take a look. It's actually hanging in one of the top 20 most iconic 5-star hotels in the world at the moment. And when you see it from a distance, you're just going to see the words, what is structure? But if you look closer, you will see that the structure of the letters is itself made by that exact same question again. And if you look even closer, it keeps on going forever. Now, what's the point of this? You can ask the question, what is structure, using words, but that's only a very shallow, kind of one-dimensional way of asking a question. The entire art piece, by how I structure this, like the whole thing, asks this question in a completely different way. It lets you kind of experience the question, just by looking at it and kind of getting closer and going further away, you're aware of something. So this artwork both asks and answers this question, but it does so in a way that is beyond language. So language itself is very limited into what it can describe, and the law of exception is extremely paradoxical and counterintuitive. So I'm going to describe it to you using words, but it's more like I'm going to try to show you a structure from various angles, because it's almost impossible to see it from just one angle. So it can be slightly disorienting in the beginning, but trust me, by the end, you will get this easily. Now, there are thousands, maybe even millions of ways to describe the law of exception, because the law of exception describes everything. And so every single thing around us describes the law of exception kind of in action. It's doing everything that's happening around us right now at all times. So let me start by taking the Earth as an example. We all know that our planet is surrounded by a vast amount of empty space. Now, if empty space is the rule, is the current trend, let's say, what would be an exception to empty space? The answer, of course, would be something, anything that isn't empty space. So the Earth, our planet, is an extremely rare exception in space. Every star, planet, and moon is. They're all very exceptional because there is a huge amount of space. Now, Earth is also a planet with life on it, famously. Even though all planets and stars and moons are extremely exceptional in space, the Earth is exceptional again because, as far as we can prove it, we seem to be the only planet amongst all of them that seems to have biological life. So Earth is an exception in space, and biological life on Earth seems to be exceptional to the no life that we see elsewhere in the universe, everywhere else. Let's move on over to the moon. Out of more than 600 moons in just the solar system, did you know that our moon up there is the only one that appears more or less exactly the same size as the sun in the sky? So there are hundreds of moons, they all venture between their planet and the sun, but ours is the only one, the exception, that creates an actual perfect eclipse because it's the same size as the sun. So the moon is extremely exceptional, again, by its placement. And this literally is the only one of its kind, the only one that does an eclipse like that, as far as we know, in the known universe. So a very big exception again. Now let's make it a bit more personal for you. Watching this, what about you? If you could go 1,000 years backwards in time, to the year 1025, what do you think would the odds be that you are going to be born 1,000 years from that moment? So the chances of you, yourself, existing right now are just as unlikely as the solar eclipse. You yourself are as big of an exception as everything else. There's nothing at all that exists that is less exceptional than the Earth, the Moon, the solar eclipse, or you. Everything that exists is exceptional. So Florian, you say that you have a law that applies to absolutely everything, and you say that you can prove it. Well, here you go. Every single thing that exists is a monumental exception. Everything obeys the law of exception. Everything is exceptional. There's absolutely nothing normal that exists at all. Every object, every form of life, every voice, every hair color, every single strand of DNA, every drop in the ocean, every single thing that exists is exceptional. Ultra, ultra, mega, mega, ultra rare, unique, one of a kind in the universe. That goes for me, for you, it goes for everything. You're an exception, I'm an exception. Every human being is a unique variation of the human shape. Every galaxy, every planet, every atom, everything we see around us is an exception. No matter how boring we may think of our surroundings, no matter how much we've gotten used to living as human beings, no matter how much we may fool ourselves that life is full of normal things, if we allow ourselves to think on a cosmic scale of thousands of years and millions of light years of distance, then our lives are stupendously, outrageously, unlikely exceptions. Now let me show you why. So this is what I call the prime formulation of the law of exception. It's not complete because it's made of words, symbols, but it's currently the most useful way I think I have of formulating it in order to explain and show you how and why it explains everything. So here it goes. In order for any rule, structure, or order to be true, to work, to be real, there must be an exception. Now, like I said before, to most people at first sight, it's just going to look like a bit of a quirky or odd sentence. So let me walk you through it step by step. If we simplify for a second and say, just to be ultra clear, if we say that there must be an exception to everything, then what is the exception to this rule itself, right? It means that if there must be an exception to everything, that if that's true, there must be one law, one rule to which there's no exception. One rule, one law that is always true. So if it's true that for anything to be real, for anything to be true, for anything to work, there must be an exception, that means that there also must be one rule that is always true, one rule that is without exception. And that rule can only be this rule, the law of exception. It's this structure, this one structure that is both the rule and the exception to its own structure. It's the ultimate exception. It's the law of exception, the one exceptional law, rule, structure that is always true no matter what. And that's why everything is exceptional, because that's what the law forces it to do. So how does this law of exception, succeed? Because we now clearly see that everything that exists is exceptional. How the hell does a law force everything to be exceptional? Let's formulate it like this. Everything that is an exception, and everything must also have an exception. What does that mean? For anything to be real, there must be an exception. What's that exception then? That exception is time. everything is exceptional because everything is temporary. That's why I also like to call the law of exception the law of time. So we can kind of formulate it like this. Anything that's real or true is temporary, must be temporary. Now, how does this lead to an entirely new way of understanding numbers, physics, energy, black holes, everything? Let me show you how. And keep your mind open. This is like looking at an artwork. For anything to be real, to exist, it must have an exception. And that exception is time. It must be temporary. So that's why everything is exceptional, because everything is temporary. So anything that does not have the exception, anything that's outside of time, can't be real. And this brings us to two very famous concepts. The concept of zero, or randomness, and the concept of infinity, or determinism. Because both of these are central to maths and physics, but both actually do not have an exception, because both zero and infinity are not temporary. Anything that exists must be temporary. Infinity, forever, is not temporary. Zero, never, is not temporary either. And therefore, both of them cannot exist in reality. There is no nothing, there is no everything. It means that absolute randomness, so something without a history literally, does not exist. And neither can anything ever be absolutely complete or determined, infinite. It doesn't exist. So one of the biggest questions in philosophy, and also in math, etc., is the world random or determined? Do we have free will? This has been a completely wrong way of looking at the world. Both randomness and determinism don't exist at all. They never existed. So let's look at proving this for a second. If you think of randomness, absolute randomness, no experiment ever in history has created something absolutely random, ever. So you've heard of random number generators on your computer, but random number generators actually don't generate random numbers. They just usually take the time and the date of your computer, and then they do a number of very complex programs with that number to come up with a very complex number that you couldn't really guess beforehand. But it's not actually random at all. Even a big random number will always be made from the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So even there, you can still predict something about it, which means it's not really completely random, because for something to be completely, absolutely random, you should not be able to predict anything at all about it. If you can predict anything at all about something, then it's not random. And so in all of the scientific research and experiments that has been done over the last hundreds of years, nothing absolutely random has ever been used or produced. Why not? Because absolute randomness cannot exist. The law of exception forbids it, and this is evident in the world. There is nothing random that can exist. Same for determinism, for infinity. Nothing in the world is ever determined. Nothing is ever sure, right? We know this because no experiment that we can do will give us 100% success rate. And this is why not. Many of the quantum physics people who are watching this are now looking at this and going, what are you saying here? Are you saying what I think I'm saying? Yes. The reason that quantum determinism, meaning exact action and reaction, calculatable action and reaction on the smallest possible scale that we know of, that we can perceive, would mean absolute determinism. If we can predict what happens there on the smallest level precisely, accurately, always, that would break the law of exception, because that would mean an infinite result, infinite control, and that's impossible because both randomness and infinity are not possible. Both of them are not temporary, so they break the law of time. They break the law of exception. And therefore, in this reality that we are in, they cannot exist. So, zero is a concept that can exist in our mind. It's like a dream, but it's not real. We have confused our mental world, our dream concept, with something that could be in reality, but in this reality that we live in, there is no randomness. Same for infinity or determinism. It's a concept that can exist in our minds, but it cannot exist in physical reality. In physical reality, nothing can be determined. And that is why we have quantum uncertainty. That's why no matter what scientists do on the quantum scale, they can never ever, and have never for the last 100 years, ever produced a 100% predictable result. They cannot really describe the initial state 100% perfectly. They cannot describe what's going to happen 100% perfectly, and they cannot describe the result 100% perfectly. None of those steps is possible because all of them break the law of exception, which is why we have quantum uncertainty. It's just the fact that the law of exception is true, and because the law of exception is true, that's why we have quantum uncertainty. So there cannot be any absolute randomness or determinism. So what is there then? Well, when you wake up in the morning, your day is not random. There's nothing random about it. It's also not fixed or determined. Instead, there is a range of options that can happen based on your previous choices and the choices of everybody around you. That is what we call your probability. And as you go through your day by choosing your path, each of your probabilities will become an exception, because everything that is an exception. It's a choice that was already made. Everything is an exception. Everything has been determined by choices that were made earlier. And that brings me to the first probability numbers, the probability limits, what we call the lowest probability limit, or LPL, and the maximum probability limit, or MPL. And these two numbers are, so not zero, because the lowest probability for anything to happen in the universe is never zero. It can't be zero. The lowest probability for anything in the universe is 0.0 infinity 1. But in this case, when I'm using the infinity symbol, I don't actually mean infinity, because we know that doesn't exist. I'm just using it as a placeholder to mean the maximum amount of nines, of zeros in this case, possible. So it's not really infinity, it's just a very, 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 very tiny number. The tiniest number possible, the tiniest amount possible. The maximum probability limit is 99.99 infinity. But here again, infinity doesn't mean real infinity, it just means the biggest amount of nines possible, meaning the largest possible probability, the largest possible amount that is possible in the universe, but not infinity. So we don't have zero or infinity, those don't exist. But we have what does exist, which is the lowest probability limit and the highest probability limit. And so what's special about this is that they present the boundaries of time. Everything around us is an exception, and everything around us has a probability. And that probability is limited, meaning nothing can ever completely stop existing. Energy cannot be created or destroyed, and nothing can ever be completely complete, be completely perfect, stop being temporary, be forever, because that's also something that time, the law of exception, just does not allow. So something can be 99.99999% stable, but never 100% stable. It must remain temporary. And something can be 0.00001% stable in time, meaning it only exists for like a microsecond and then it becomes something else, but never shorter than that. So there's never a 0% chance of anything happening. The minimum amount of probability for anything at all to happen in our universe is never zero. It's always 0.0 infinity 1. And the highest chance of anything happening, the highest probability of anything happening is always 99.99. That's why there's no scientific experiments that can ever produce 100% certainty, because even if you do an experiment 100 times and you get the same result 100 times, the 102nd time, something else can happen and suddenly you will get a different result. That's why no matter how much we train for, like a marathon event, even if your health is great, still a car accident can happen, or you can get injured, or something can always happen. And something can always happen. Why? Because of time, the law of time, the law of exception. Everything must be temporary. And the maximum temporariness, let's say, the maximum stability within temporariness is 99.9999%. That's the maximum probability limit. Or on the lower end, the chance that you're going to be here tomorrow in this same form, or that this is going to happen tomorrow, is very, very low, but never completely zero. So that gives us the first two numbers, and especially in this point, the number 0, or what we call probably 0, because it's not the old 0 which doesn't exist, it's the new 0, what I like to call probably 0, and its value is not 0, it's 0.0 infinity 1. And so this is actually the first number in the probability number set. Now, if we want to add another number, so if we want to add 1 to 0, because normally we have, 0, then 1, 2, 3, etc. So we have probably 0, but then how do we get probably 1? Well, we actually cannot add just 1, because 1 is a complete whole. The assumption in all of math is that every number is a complete unit. And complete units don't exist because complete units defy the law of exception. Everything must have an exception. A complete unit without some imperfection, without some exception, doesn't jive with reality. It cannot describe reality accurately. So instead of 1, what we're going to do is we're going to take the lowest probability limit and we're going to deduct that from 1, giving us a value of 0.99 infinite. And again, infinity here doesn't mean actual infinity, it just means the largest number of 999s possible, right? So that gives us closest to 0, probably 0, and closest to 1, right? So these two are no longer fixed numbers now. They're no longer whole, they're no longer complete. They are both ranges. They are temporary structures. In the moment when we do math with them, we are kind of saying, well, what if I take a structure that's nearly 1, nearly complete, and that's what I'm going to use to calculate. And so that way we respect time, we respect the law of exception with numbers. So we have nearly 0, 0.001, 0 infinity 1, plus 0.999 infinite. And if we add these two together, we get, paradoxically, the whole number 1, because closest to nothing and closest to 1, add them together, you get 1. So right away, this here is kind of a mathematical proof that any whole that we see, any one unit, any completeness that we see in our universe, in our experience, is never one whole, because for anything to be real, it must have an exception. And so when we see 1, a real one, a one that follows reality, can't be a whole. And the probability math instantly proves that, because the one that we have isn't a complete one, it's one with an exception. It's one with the lowest probability limit deducted from it. And so if we then go for 1 and we add another probability unit of 1, which is in fact the value of 0.999999, etc., we get 1.99, then 2.99, then 3.99, 4.99, etc., etc., etc. Yeah, so this is the new line of numbers that we now get. And here's the cool thing. With these numbers, probably 1, probably 2, probably 3, probably 0, probably 4, probably 5, we can do all of the math that we already do as normal, only this math does never give you an exact answer. It gives us a probability, and it does the most amazing thing. Why? I told you, in this universe, there's only probability, choice, and exception. So, if we do regular math with regular numbers, what happens? We take 1 plus 1 is 2, right? So we take a whole unit, complete, another complete, we put the, equals 2, boom, it's 2. But what happens when we use probability numbers for this? So let's say probably 1 plus probably 1 is. Now, nothing happens because probably 1 isn't a finite number, it's a range. It's fuzzy inherently because it's a temporary structure in time. So is the second one. So we have two structures here that are both not finite. And in order to be able to make an actual calculation with them, we have to collapse their probabilities. We have to first make a choice. So are we going to go for 0.9999999 or are we going to go for 0.99 or 0. The number of nines that we choose here is the definition, is the resolution that we will be working with in this particular math example. And it's only when we make that choice that suddenly the equals does its thing and we get probably 2. But probably 2 again is not a fixed, finite, complete, something. It's again, it's a probability. It's probably 2, so it's somewhere around 2. Now, if you look at this line of numbers, so we have math, where now for every equation that you do, you have to actually choose how to interpret each numbers, which is literally what we do every day. We look at the information, we look kind of at the input, and then we choose, and that choice determines the outcome. So the math follows the conscious experience perfectly, and look at these numbers. So you can still do regular math with these, but you get probabilities. But there's no even or odd numbers here. They're all the same. Duality doesn't exist in this number series. There are no prime numbers in this thing. And there are no infinite numbers. So there's no 0, there's no infinity, which is why these numbers allow us to actually calculate through the famous singularity, the edge around black holes, and actually explain what is happening inside of there. Now I'm going to do that in a different video, but that is the power of these numbers. And so that is the short overview of how the actual law of exception, for anything to be real, true, effective, to work, there must be an exception. That law, that structure led me to constructing numbers that actually follow the truth of reality, which is that there is no randomness. Nothing in the universe is absolutely random. Everything is related to each other, and there is always some meaning to everything, never zero. And at the same time, nothing is determined. It can be. Quantum physics, thousands of scientific examples and tests prove this. Nothing can create determinism. But probability and exception are real and provable. You can do it very easily. I have my dog Obi-Wan here, and if I go to the park with him and I want to have him do like a lot of tricks, then I can increase the probability of him, actually obeying me and doing all the tricks with me by bringing a lot of great treats for him. Now, if I don't bring the treats, I immediately decrease the probability of him actually focusing on me and doing all the tricks. If I bring the food, I immediately increase the probability of him, playing with me and actually doing all the tricks that I want him to do. So we as humans can influence the probabilities, and this is measurable everywhere. Anybody can set up, a dozen simple experiments that can prove to you instantly and easily that probability and the changing probabilities through our choices are real and measurable, and that every choice that is made always leads to an exception. And an exception is just something real, something that you cannot change anymore. You're here, the earth is here. You can change the future, but not the past. And why that is, well, we're going to talk a lot more about time and kind of time's secrets as I explain to you guys more how time actually works, what time actually does, because the structure of energy, the law of exception, is all about the structure of time. And we're going to be doing things like unifying electricity with food and even money. We're going to be unifying so many aspects of life into this one thing and show you that the law of exception explains everything. Now, in order to make these numbers a new mainstay for actually doing high-level math, I needed to adjust, or I needed to give them a number of axioms, so a number of rules on how to use them. So I created 7 axioms for using these numbers, and you can download the document that shows you the actual in-depth axioms, because there's a long story and long motivation also as to how exactly to use these to get the right answers to your questions. And yeah, I invite you all to try them out, because actually it's not so hard to apply this to physics. It's not hard to see why numbers that literally have non-determinism inside of the numbers are the way to unify the quantum and the Newtonian physics, which it 100% does. All of that hopefully already online in future videos. If you are watching this and you're one of the first, so there's no future videos yet, please like and subscribe, comment below what you think about this, kind of discovery slash invention. And I'm really looking forward to quickly publishing the next videos in this series. In the next video, I'm going to be looking at the structure of, so I'm going to be explaining the structure of prime numbers. Why do we have prime numbers? You see that these numbers actually make them disappear, so I can just turn them off. But I also figured out actually what makes them happen when you don't use probability numbers. And this is a really like an old, deep mystery that people were talking about, 3,000-4,000 years ago. People were wondering what the prime numbers were. So in the next video, I'm going to explain exactly what prime numbers are and how, what is the structure that leads to them being real. So thank you for watching, and see you in the next video. Ciao, ciao.